Hey everyone, and welcome. Today we're going to talk about a really clever shortcut that's making AI a whole lot smarter and faster. It's all about teaching machines to learn from this massive ocean of data that up until now they've pretty much just ignored. So let's dive in.
So let me just start by asking this. What if an AI could learn from everything? Not just that tiny, perfectly prepared slice of data we hand-feed it, but from that huge, messy, chaotic ocean of information that makes up like 99% of all data out there?
And yeah, that's the data reality we're living in. A staggering 99% of the world's data is what we call unlabeled. It's just raw stuff, images, text, audio, with zero context. So that leaves this tiny, tiny 1% that's all neat and tidy for a traditional AI to learn from. I mean, just think about all that wasted potential, right?
And this right here, this brings us to what's known as the big data problem. You see, preparing that tiny 1% of data isn't just a bit of work. Oh no, it's a massive, monumental bottleneck that's actually holding the entire field of AI back.
So you might be asking, why is this labeling thing so hard? Well, for starters, it is insanely expensive and it takes forever. I mean, just imagine you need actual human experts like doctors looking at medical scans to sit there and label every single piece of data. That kind of process it can't scale when you're talking about billions of data points. It's a non-starter.
Okay, so clearly this approach isn't working. We need a better way. There's got to be some kind of middle ground, right? A sweet spot that can bridge that gap between having perfectly labeled data and having no labels at all.
So to find that sweet spot, let's just quickly look at the two extremes. On one hand, you've got supervised learning. Think of this like a student who has a perfect answer key for every single question. Yeah, it's super accurate, but making that answer key, that's the whole bottleneck problem we just talked about. Then on the other hand, you'd have unsupervised learning. This is more like a detective thrown into a room with zero clues and just told, hey, go find some patterns. You know, it can work, but it really doesn't have any clear direction. So yeah, neither one is perfect.
And this is where our hero enters the story. Semi-supervised learning. And the core idea? It's actually brilliant in how simple it is. You take that small, precious bit of labeled data and you use it to start making sense of that giant ocean of unlabeled stuff. It's like you're getting the best of both worlds, right? You get the pinpoint guidance from the labels, but also the raw power and scale of all that unlabeled information.
Okay, so that sounds awesome in theory, but how does it actually work? Like, what's the magic trick here that lets an AI make sense of all that messy data? Let's get into it.
You know, this quote pretty much nails it. The model essentially teaches itself. It's really that simple. It uses the little bit that it already knows to make these educated guesses about all the stuff it doesn't know, and by doing that, it just keeps getting smarter and smarter with every single go-around.
So let's walk through this with a super simple recipe called self-training. Okay, step 1. You start by training a really basic model on a small labeled data set. Let's say 500 pictures you've already marked as cat or dog. Easy enough. Step 2, you take that model and you just unleash it on a huge unlabeled data set, and you let it guess. Cat, dog, cat. Step 3, and this is the really clever part, you look at all its guesses and you take the ones it's most confident about and you basically say, okay, we're going to treat these as if they're real labels now, and you add them back into your original training set. And then, step 4, you just repeat the whole thing. You retrain the model with this new, slightly bigger data set. It's this awesome feedback loop that just keeps getting better.
And this isn't just some, cool academic theory. No, this is already out there in the real world, giving AI some serious superpowers. Let's look at a few places where you probably run into this every single day and don't even know it.
Take healthcare, for instance. Labeling an X-ray? That takes a doctor's time, and that time is expensive. But with this method, a model can learn from, say, just a few hundred scans that an expert has already labeled, and then it can teach itself by going through millions of unlabeled ones. The result? You get faster, more accurate disease diagnosis. It's a game changer.
Or think about your email inbox. Your spam filter learns at first from what you personally mark as spam. But where it gets really, really good is when it starts analyzing the patterns across billions, literally billions of other unlabeled emails zipping through the system every day.
How about finance? Thankfully, there aren't a ton of confirmed fraudulent transactions for an AI to learn from, but that's the beauty of it. A semi-supervised model can take that tiny sample of known fraud and use it to spot similar, suspicious patterns across millions of totally normal, unlabeled transactions.
And yeah, finally, those voice assistants we all have. You know, in our homes, on our phones.
It would be literally impossible for humans to sit down and transcribe all the audio in the world. So instead, they learn from a small set of perfect transcriptions, and then they get way better by listening to huge amounts of unlabeled audio data.
So it's pretty clear this hybrid approach is incredibly powerful. But to get the full picture, we got to be honest and look at the advantages and the very real challenges that come with it.
The upsides are pretty obvious, right? You're getting way higher accuracy with way fewer labels. That slashes the time and money you'd spend on prep. It scales up beautifully, and honestly, it's one of the most practical AI tools out there for solving real-world problems today.
But it's not all sunshine and roses. There are definitely challenges. The biggest risk? A nasty feedback loop of errors. Here's what I mean. What if the model makes a mistake, but it's super confident about it? Like, it labels a wolf as a husky. Well, it's going to treat that mistake as a hard fact for the next round of training, and that one little error can get amplified, basically teaching the model the wrong thing again and again. So, it means you have to be really careful about how you decide which of these self-generated labels, these pseudo-labels, the model should actually be allowed to trust.
So as we're wrapping this up, it's pretty obvious that the future of AI isn't just about grabbing more data. It's about being way smarter with all the data we already have. The good, the bad, the messy, the clean, all of it. The real power is in using all of it wisely. And that kind of brings me to one last question for you. If you had this tool, what problem would you go out and solve with it?